Okay, so our presentation today will be on whether or not we can predict whether or not a men's college basketball team will make the NCAA tournament. So this is a classification problem, and our question in more detail is, can we determine whether or not a college basketball team made the tournament based on their efficiency/rate stats? And if so, which factors can help us determine if the team will make it to the tournament? So this data set is called the College Basketball Data Set by Andrew Sundberg. We found it on Kaggle. And so it covers years from 2013 to 2021, but we're only going to use the 2019 data because it's the last full season available, and also less important because UVA won. So there's a bunch of predictors in this data set, but the only predictors we want to consider for our models are adjusted offensive efficiency, adjusted defensive efficiency, effective field goal percentage shot, effective field goal percentage allowed, the free throw rate, the three-point shooting tempo, the adjusted tempo, which is the number of possessions per 40 minutes a team would have against an average Division I team, and the win rate, which we calculate ourselves using the number of wins, which is the W column in the data set, over the number of games, which is the G.
One important thing to notice from our exploratory data analysis is that there's a lot of multicollinearity in our data. A lot of our predictors depend on other predictors, which makes logical sense because you would expect a team with a better average defensive efficiency to allow a lower effective field goal percentage on defense, for instance. So a lot of multicollinearity, but it's also important to notice that there is a difference in center for the distribution of teams that made the tournament versus teams that didn't in a lot of these categories as well. Next slide. Yep, perfect. So our logistic regression model looked like this. We had two significant predictors. We had win rate and adjusted offensive efficiency. At alpha equals 0.05 for the Wald test, none of the other variables were significant. Win rate being significant is not surprising, as winning games is the most important determining factor for getting into the tournament. However, it is interesting to consider that only offensive efficiency is significant, which suggests that a team's offensive ability is much more valuable than a team's defensive ability for determining if the team will make it to the tournament. Our logistic regression model had an AUC that is very high at 0.9695. And our k-fold predicted error rates for 5 and 10 were both slightly higher than our observed test error rate of 0.0562. If you look at our confusion matrix down in the bottom right there, we actually only had 1 false positive and 4 false negatives in our test data. So our false positive and false negative rates are actually fairly low, which is a little surprising given that our data is not evenly split, since many more teams miss the tournament than make it. Our linear discriminant analysis results look like this. As I just was talking about, you can see in the prior probabilities, many more teams don't make the tournament than do. There are only 20% of teams that actually make the NCAA tournament. Looking at the group means for the two classifications, you'll notice that they're all relatively close together with the exception of win rate. Win rate's a percentage. So 48% versus 74% is a pretty major difference. And you can see the same while looking at the coefficient of linear discriminant, where for win rate, it's 3.03, where everything else is less than 0.1. So the win rate is definitely the most significant predictor, both here and in the previous logistic regression model. The AUC for our LDA model was also very high at 0.957. And we see a similar pattern with our k-fold predicted errors and our test error. The confusion matrix is almost exactly the same, with the exception that our 1 false positive from logistic regression has now become a true negative.
All right. So with classification trees, we've done recursive binary splitting, prune trees, and then random forest trees. And just to start us off for most naive model of the three, our recursive binary splitting model, As you may see, we use significantly more predictors than we do with the other two, with the two previous models. Uh, of course, sort of not mentioning the fact that only a handful of the variables were significant in the first model. But as you may see, win rate and offensive efficiency are still the most important predictors, as if you look, the very top decision is for win rate. There's a very clear cutoff at 55% for whether you will make it or not. Then followed by offensive efficiency, and then mostly split off by more minor variables. And we observe an error rate of 0.06, which is fairly low compared to our previous models. But we still experience relatively high false negative rates, despite the fact that we have the same exact amount of false negatives and false positives. Once again, that is due to the fact that we have uneven splits for teams that made it and teams that didn't, just due to the nature of the data set. Moving on. For a pre-tree, we have a significantly smaller tree with only two decisions. One with the win rate, which has now been increased to 55%, not that big of an increase, but nonetheless, and offensive efficiency. In which case, the suggestion here is that a team has to have a high win rate and high offensive efficiency. Once again, suggesting that defensive efficiency does not actually play a high role in our predictions. That said, this results in a slightly higher error rate and a significantly higher false negative rate, as it is significantly easier to increase that with false negatives, as we have significantly more false positive. As we have significantly more positives. And moving on to our random forest. Once again, you may notice that win rate and offensive efficiency are still the most prevalent predictors by far. Although looking at mean increase Gini and decrease accuracy, you can actually see that's not as drastic as it was with previous models. Nonetheless, the two variables still make majority of the prediction, and surprisingly, with random forest, our error rate actually goes up to 0.11, which is unusual given the nature of trees usually. Although our false negative rate falls down to 0.37. Once again, due to unbalanced nature of our response variable, it's much easier to get a higher false negative rate. And we'll mention ways that we could possibly defer that, but as of right now, our models are more oriented towards false negatives.
Okay, so how did all the models do just as a whole? So with regards to predictors, pretty much every model used every single one of the important predictors we considered, with the exception being the prune tree. We did come up with a reduced model for the logistic regression model. However, we conducted the likelihood ratio test, and that revealed that the full model was significant over the reduced model, so we can't just choose the reduced model. And so for the test errors, it ranged from 4.49% in LDA to 11.36% in random forests. False positive rates are kind of the same, I guess, from 0 to 4.76. But the most important one, to us at least, was the false negative rates. As you can see, they're all pretty high values. And so we considered lowering the acceptance threshold rate from 0.5 to 0.2. And so what that did is it did reduce the false negative rate, but it also caused the false positive rate and test error rate to skyrocket. So we decided to just keep it at 0.5 and accept a higher false negative rates. And so as we did mention, it's very unbalanced between teams that did make the playoffs and teams that didn't make the playoffs, about a 80%, 20% split. And so that will result in more teams being predicted to not make the playoffs, and so therefore a higher false negative rate, which is exactly what we see here. And so in conclusion, we had moderate success in prediction strength with a test error rate around 7.5% on average. And seen from logistic regression and the prune trees, the most valuable predictors were win rate and adjusted offensive efficiency. And we had high false negative rates unless adjusted at the cost of test accuracy and the false positive rates.